Hey, it's Dr. B here, and I need to tell you that we're so proud of our eyes and how much we can see with our eyes, but when you really take a look at it, our eyes kind of suck. I mean, there's what we can see in terms of visible light right there. However, the entire electromagnetic spectrum, that is, if you will, all possible wavelengths of light, covers quite a bit that we cannot see. We have to use machines to see it, an infrared spectrometer, right? An X-ray spectrometer. We can generate these things. We can detect these things. We use these things now more and more for communication, for health reasons, things like that, but there's so much that we do not see. As we are proceeding in this continuum, we're going from a very high wavelength in the thousands of meters to a very short wavelength in the much less than a nanometer. And so the frequency is getting higher, and therefore the energy is getting higher. Therefore, we're going from a safe, often type wavelength to a dangerous, constant type wavelength. I say often because note that when even the wavelength is in the thousands of meters, the frequency is still in the thousands of times per second. So that doesn't even come close to it. So frequency is, generally speaking, a very high number. And these numbers here are just, notice that they differ always by 10 to the 8th, which is the speed of light, right? 3 times 10 to the 8th meters per second. So that's a little bit about the electromagnetic spectrum and how much we cannot see. It helps to know that as you go from red to violet, you're going from about 700 nanometers for the red light to 400 nanometers for the violet light. It's just handy numbers to know. It seems to show up quite a bit. And when you get beyond red, you're clearly going to be in the infrared. And when you get beyond violet, you go to the ultraviolet. That helps us remember these sections. And that's right here about is when you're going from safe to dangerous. This is the electromagnetic spectrum.